Hello, good morning. How are you? You okay? Are you okay? Can you hear me well? Can you? Are you there? Can you tell me you can hear me? Hello? Okay. So, now remember we're going to correct our yesterday's mock exam, and you had to have your exam before you, and I need your contribution. So, let's stay focused on our task and go to the first exercise. Okay, so you have to match all these concepts about energy. Remember, this is a kind of exam, this is a kind of review of many things we know, we have studied. It's now, okay, so let's start for number one, talking about mechanical energy, and you have to choose one answer here. Maybe A, the movement or flow of electrons, maybe B, C. So what do you think is the right answer for mechanical energy? What do you think? What do you think? Talking about mechanical energy. So you can choose between A, B, C. C impossible because C is 2. So you think Ines thinks is E, and that's right. That's right. Okay, so remember that mechanical energy is a kind of energy that is due up. Is due. This is okay. So 1E. So mechanical energy can be divided into two kinds of energies. So one of them is potential. It's called potential. You remember Unit 4, potential energy, due to its position, and the other kind of energy is the energy that is due to the movement. So 1E. Very good. Go to chemical energy. Now talking about chemical energy. It's chemical energy is what you think. What you think? Chemical energy, movement of flow of electrons, the motion of particles, atoms, or molecules in a substance. This is difficult. This is difficult. But somebody said, Ines, very good. Ines is right. Julia, pay attention. No, it's F. Okay, we're talking about the energy stored in the bonds between atoms in a molecule. That's okay. This is the correct answer. Okay, that wasn't easy. So there's a difference between atoms in a molecule and a difference between the motion of particles, atoms, of molecules in a substance. This is different. So number 3 is F. Let's move to number 4. So electrical energy. That's easier. What do you think? Electrical energy. Let's stay focused, Eva. No. Don't say hello. We are in class now. So, talking about electrical energy. What do you think? Electrical energy is, yes, okay, is the movement or flow of electrons. Very good. So go to number 5, light. What do you think? Light. What is the correct answer? The correct definition for light? Light. Light is light. Very good, Ines. Very good. So light is electromagnetic waves that can travel through a vacuum. Okay, el vacío, the faster form of energy. Easy. Now, number 6, another difficult kind of energy. So, 6, thermal or heat energy. You remember thermal energy. And remember that thermal energy was the energy due to heat, and heat is the motion of particles, so B, the motion of particles, atoms or molecules in a substance. Very good, Rodri. Very good, Valeria. Very good. And finally, nuclear energy. Want to know many things about not nuclear energy, but atoms. And in this case, talking about D. So the nuclear energy is the potential energy stored in the bonds in the nucleus of an atom. Very good. So nuclear energy. When we talk about nuclear energy, we're talking about the nucleus of an atom. So in this unit, we're going to study the nucleus of an atom. You're going to understand what electricity is. You need to know about atoms. Very good. So D. Very good. So go to the next exercise. So number two. I think this is very easy. But we're talking about energy. So the first one is 2-1. The sun produces thermal and light energy. So this is the kind of answer you have to put here. And the guitar, what kind of energy produces a guitar? What kind of energy does a guitar produce? What do you think? Talking about the guitar. Many of you are studying music. What do you think? Ines says a guitar produces sound energy, but I'm not very sure. What do you think? Do you agree with Ines? A guitar produces sound energy. Very good. Now you can see here children that are playing in a park maybe, and they are moving up and down. So and these children produce what kind of energy? Are they producing or are they using? What do you think? Children. Okay. Children, pay attention. They are up and down. They are playing with their position. Very good. With their position, and they are playing with movement. So this is the definition of mechanical energy. Very good, Ines. Wow. And Julia. Very good. Now, this is interesting. What about food? What kind of energy does fruit produce? What do you think? Food. We need food to get energy. Valeria, you're right. They produce thermal and gravitational energy. Talking about children, but this kind of energy is best known as mechanical energy. Very good. And food produces chemical energy. We use the chemical energy that is stored in the food we eat to get energy. Very good. And that is really easy. Fire. What kind of energy does fire produce? Fire. Two different kinds of energy. Fire. What do you think? Fire. If we are talking about fire, we're talking about. I'm waiting for you. We need time, but you got to go faster. Very good, Ines. Very good. light and heat energy. Very good, Miguel. Very good. And Valeria, very good. Thermal is the same as heat. Thermal energy is the same as heat energy. Very good. Celia, thermal, but not only thermal, but also light energy. Okay, you have fire, you have light. Very good. And finally, this is the easiest of all of them. The wind. And you see here the drawing. The wind produces what kind of energy? What kind of energy that can be converted into electricity? Wind. What do you think? Wind. Wind. Yes, mechanical energy, but you can also say wind energy. Very good, Rodri. Wind energy. But wind energy is just a form of mechanical energy due to the movement of the wind. Very good. You did it very well. But not all of you sent it out to me the other day. This, number three. So you have here the name of 4 sources of energy. And you have to select the odd one out and write why. So you have coal, you have oil, you have wind, and you have gas. And you need to select one of them, which is, according to you, the odd one out, the intruder in this group. What do you think? Julia says wind, but she's the only one. Valeria, you good? Wind. Do you agree with them? Only two of you are taking part in this class. Very good, Julia. Very good. So the odd one out is wind. And Julia is right when she says that wind is the only kind of energy in this group that is renewable. Because coal, you can waste of coal. You use it, you can waste it. And oil the same, and gas the same. But wind can be wasted. Okay, we have wind with us. Very good. This is a clean source of energy, wind, and renewable. Very good. So now stay focused. Number 4.1. You have to complete the sentences and with these 2 words. One of them, temperature or heat. So we use to measure how hot or cold something is. Which is the correct word in this sentence? What do you think? Good. Temperature. We use temperature to measure how hot or cold something is. Very good. And you are seeing it today when you see some images about people that are tested about their temperature. Very good. Now, next. 4.2. When we add thermal energy to a substance, we need a verb. In this case, what are we doing when we add thermal energy to a substance? We temperature it or we heat it. When we add thermal energy to a substance, we heat it up. Very good. We heat it up. Okay. Very good. You have to be correcting your exercises. Very good. Because many of you sent it yesterday at night and I couldn't do it. So you have to do it now. Very good. So 4.3. We use the Celsius scale to measure what? To measure heat or temperature. Now 4.3. We have different temperature scales. One of them, the most used for us, is Celsius scale. You go to the United States or you go to the United Kingdom, they use another kind of scale. This is not Celsius, this is Fahrenheit. But we use the Celsius scale to measure what? Very good, Valeria Rejon. Very good, very good. Okay, but there are only 3 or 4 people out of you that are taking part, and I like all of you, no matter you were wrong. Remember, this is not exactly an exam, but a mock exam is not the same. Very good, very good. So, the correct answer is temperature. Let's go to the next one. So, a thermometer is the instrument to measure what? A thermometer. Fahrenheit, take care, Rodri, spelling, Fahrenheit. Okay, final T. So, 4. A thermometer is the instrument to measure what? To measure temperature. Very good, very good, very good. And finally, 4, 5. When we a substance, the of the substance increases or the substance change state. We need 2 different words. 2 different words. When we a substance, this kind of verb, this is English. This is not science. This is English. When we need a verb here. When we a substance, the of the substance increases or the substance changes state. So the first one is Eva is right, Valeria is right, Valeria Gomez is right for the first word, but the second one is temperature. Very good. So when we hit a substance, the temperature of the substance increases, of the substance change state. Very good, very good. Now, I need your contribution here. Number 5. Answer the following questions. And the first one is 5.1. What is the characteristic of a material that is a heat conductor? What makes a material a heat conductor? Why do we know that a particular material is a heat conductor? Why? You need to write some words there. You need to write some words there, waiting for you. So, how do we know if a material is or not a heat conductor? And Eva says, the heat passes. Attention, your syntax. Attention, heat. Third person, the singular. Very good, very good. So, the heat can pass easily. Yes, very good. And easy. Next, 5.2. And the characteristic of a material that is a heat insulator? An insulator? Why do we know that a material is a heat insulator? Why do we know whether or not a material is a heat insulator? What do you think? What do you think? You need to take part, all of you. Yes, Celia, you're right about 5.1. Yes, you're right, but we are now in 5.2. This is the opposite. Okay, can't pass. By the way, can anybody tell me an example of a heat insulator? An example of a heat insulator? I'm looking now for an example of a heat insulator. An example. Looking for an example of a heat insulator. Imagine winter and there is cold and we have a body heat. We don't know to lose it. We don't want to lose it, and we A heat insulator is not a metal. No, you are wrong, Julia. Plastic could be, very good, Valeria. Aluminium is a heat insulator, yes. Yes, a jacket, fabric, very good. The door could be. No, Sandra, a stove. Is the English for our Spanish, estufa. No, you're wrong there. Aluminium could be, very good. Fabric, aluminium, paper, very good. Wool. Now, 5.3. Which materials are good heat conductors? What materials are good heat conductors? You can list some of them. Yes, Celia, you're right. Yes. But stay focused. 5.3. I want the name of some materials that are good heat conductors. Material. Aluminium is not a conductor. It's the opposite. Valeria. Imagine you bring with you a sandwich from your home to the school. You don't want it to get cold, and you wrap it up in aluminum foil, aluminum paper. Why? Because aluminum paper, aluminum foil, is a good heat insulator. It's the opposite. So, materials as heat conductors could be all metals. Okay, nearly all metals, not aluminum in this case, not aluminium. Very good. So, and heat insulator, we know that we have clothes, fabric, tela, fabric, it's paper. Good, very good. Now, what about 5.5? So, how does heat travel between a warm object and a cooler object? How does it travel? Brass is a good heat conductor. Now, 5.5. We need two words from pa to pa. How does heat travel between a warm object and a cooler object? And heat travels from pa to. Can you follow me? It's difficult for you. Remember, you are correcting your exams. Nobody? Okay, so heat travels from the hottest or the warmest to the coolest, not to the cooler, the other way around, Julia. So heat travels from the hottest or the warmest object to the coolest. You have two different objects. The warmer passes its heat to the cooler. Okay, very good. So let's go to the next exercise, and you have here interesting exercise. Not all of you did it correctly. You have here a hamburger, and you have here an ice cream, and you can choose paper napkin, and aluminum paper or aluminum foil. So it's talking about the hamburger. So which kind of paper would you use to wrap the hamburger up? Because you want the hamburger to get colder more slowly. You don't want it to get really cold. You want the hamburger to keep its heat. So what do you think? Imagine you have a hamburger. You don't want it to get colder. You don't want it. So you can use a paper napkin, or aluminum paper? Which one would you use? Aluminum, yes, aluminum. Why? Why? Because aluminum paper, you can say aluminum foil, is a good insulator. So, and it's able to help out this hamburger to keep it heat. And the opposite is true for the ice cream. You want the ice cream to melt more quickly. Okay, this is strange, but you want it. Imagine. So, would you use aluminum paper or paper napkin? Which one? Which one? Rodri, if you wrap this hamburger with a paper napkin, the paper napkin is not as good as insulator as the aluminum paper is. That's why you use aluminum paper. And the opposite is true if you want the ice cream to melt more quickly. Do you understand it? Do you? Do you understand it? So, for the ice cream, you'd use paper napkin. Okay, because paper napkin is not as good an insulator as aluminum paper. Okay, very good. Let's move to the next. This is difficult. This is for you need to study. You need to study to answer rightly this question. So you have here scheme. You have liquid, gas, solid. Number one is the change for solid. This you remember this is a state of matter. The three different states of matter: solid, liquid, and gas. And you have a change of state of matter from solid to liquid. Number one. What's the name for number one? What's the name for number one? From solid to liquid. Imagine ice to liquid water. What's the name? You can choose between melting, sublimation, condensation, boiling, freezing, or sublimation. There are two sublimations. Which is the correct answer? Exercise number 7. What do you think? Yes, melting. The name is melting. And to get ice from form of solid to a liquid form, okay, to liquid state, you need to add more heat. Number two, we are in liquid form, liquid state, and we want to pass this liquid state to gas. What is the name? Imagine you have liquid water in a pan, and you want to turn this liquid water into gas. What would you do? Very good. So the name is boiling. And to do that, we need to add heat. Very good. So number three. Look here. We have gas, and we want to reverse this gas into solid. What is the name of this state? We want to turn this gas into solid. We have gas, and we want the gas to turn into solid state. This is very strange, but sometimes it happens. The name is sublimation. But in this case, we have gas, and we have these particles. To get closer and closer, we can't add heat. We need to remove heat. Tension. We need to remove heat. Tension. Okay. Why? Because in a gas, particles are separated, really separated. In a solid, they are brought together. So we get this by removing heat. And number 4 is easy as well. We have solid, and imagine we have a cream, solid, and we put this cream on our skin, and suddenly it turns into gas. We can smell it. We can smell it. So the name is sublimation as well. But in this case, it's the opposite. We need to add heat. Attention, we need to add heat. Number 4, we need to add heat. Okay. Now, number 5. Number 5. This is the change of state from a gas state to liquid. We have gas. Imagine the clouds. We have water vapor in a cloud, and suddenly it rains. So, what is the name for this? What is the name for this change of state from gas to liquid? Anybody? Julia says condensation, but she's the only one. I'm not very sure. Is that condensation? Yes, Valeria, this is condensation. And the condensation can be achieved by removing heat. Oh, okay. And finally, number 6. Number 6 is the one that is left. Number 6 is the change of state from a liquid to a solid. And this, imagine you have water, and you want to turn this water into ice. And in this case, the name is waiting for you. Number 6 here. The name is waiting. There's only one left. Nobody? Okay, can wait. So this is freezing. This is freezing, and we get freezing by removing heat. Okay, freezing. We remove heat. Good, very good. So now attention. So number 8. So light. 8.1. Light travels in. Only one of these is right. Travels in upwards. It doesn't make sense. Travels backwards. Doesn't make sense. And you can choose between some directions or all directions. Which is the correct answer for you? For 8.1. A, B, choose. You choose. A, impossible. Upwards means this in this direction. Impossible. Ines says D, and Ines is right. Okay, light travels in all directions and in straight lines. Very good. And this is basic. The speed of light. Light speed. Light travels up to 300 meters every second, 30,000 meters per second. C or D? Which is the correct answer according to you? Now we are looking for the speed of light. Yes, nothing travels faster than light. So this is the correct answer. So 300,000 kilometers per second. Let's go to the next exercise. So we have here. So the 7 colors of the spectrum of light are. You have read it, and you have to choose between A, B, C, or D. What do you think? You think is pink a color of the spectrum of light? Impossible. And what about gold? Is gold a color? Or white? Or black? Or green? Or pink? Impossible. Impossible. What about white? Impossible. So this is wrong. White is wrong. White is wrong. The only correct answer is B. Okay, red, orange, yellow, blue, green, indigo, and violet. Very good, very good. Now 8.4. Materials don't disperse the rays of light, so we the image through them. So transparent materials don't disperse the rays of light, yes or not? Transparent materials. What do you think? 8.4. Yes, A is right. That's right. That's the correct answer. We're finishing. Now, finally, 8.5 is when light hits an opaque material and changes direction. What do you think? What is the phenomenon? Density is when light hits? No, impossible. Absorption? No, because in absorption, light doesn't hit any object. Refraction? Okay, it changes direction, but in refraction, light doesn't hit the object. So the only correct answer is B. Reflection. Okay, very good. And this is a little bit difficult. Okay, it's a mix about maths. I need to frame it better. Very good. So this is a kind of math. You remember the concave polygons and convex polygons. You remember that? This is the same thing. So A. This is when light bends, se dobla, bends, because it passes from one transparent substance to another transparent substance with a different density. And this is the correct answer. So this is this phenomenon, and this phenomenon is refraction. This is refraction. Okay, and this is the picture of a lens that is concave. B. This is concave. This is concave. It's concave. Very good. So B. And finally, this is the opposite. This is the opposite. This is convex lens. Very good. Very good. See. Let's move. Now you have to say this is about sound. This is about sound, and this is very easy. Almost all of them. So 9.1. All vibrating objects produce sound. Is that true? What do you think? Is that true? All vibrating objects produce sound. Is that true? No, Ines, you're wrong. Maybe you can't hear. Maybe you can hear it. Okay, but this is true. All vibrating objects produce sound. This is true. This is true. Now, let's go to the next question. Sound energy is made by the flow of electrons, and this is weird. This is not true. This is false. Okay, the flow of electrons is the definition of electricity, not the definition of sound energy. Good. Number 4, 3. Sorry. 4, 3. Sound energy can produce change in other things, which is true. Imagine an explosion. In an explosion, this vibrations can break your crystals, your windows, so can produce changes. Yes, it's true. It's true. And next, sound has 3 main, and this is false. Intensity, speed, and tone. This is false. And this is false as well. Very good. And to finish this class, so why do solar panels look black even if they are in full sunlight? We had an exercise very similar to it in your notebook. Can anybody remember the reason why solar panels look black even if they are in full sunlight? Why do they look black? Why solar panels look black always? Why? Why aren't there green or pink or yellow solar panels? All of them are black. Why? Very good, Ines. Very good, Ines. So they absorb all waves of light, all of them, all colors. So they reflect nothing. You remember that black color is when you can't see any color at all. And white color, you can see the mixture of all of them. So solar panels look black because they absorb all rays. Okay, that was your exam. I hope you learned many things about that. You had to correct all your exercises because I'm afraid I won't have enough time to do it. And in just a minute, we're going to meet again about maths. So please, until then, if you see Javi, please say hello to him on my part. Okay? Thank you.